So this next simulation is looking at different types of waves. We looked at a wave on a string, which I think is the best one to teach types of waves, although this one's called Waves Intro. I think the first one is better. So now we can see a wave from above, and you can see the frequency at which this, you can change the frequency by turning that down, and now you can see it happens slightly less often. And then you can see what the waves would look like from above, or what they might look like from above. How would they look different if I turn down the amplitude? Well, the difference would be because they're smaller drops, we don't notice the change in the water level quite so much. What's really good about this is you can click on the side view and see how the water level changes, and clearly it doesn't change that much. Whereas if we change the amplitude, it changes quite a bit. So that's really useful to get us to understand what's going on. Again, how do we measure the wavelength in this case? We measure it from the top to the top. So let's just press play so we can see it a little bit better. So that, in this case, the wavelength is about 5 centimeters, okay? We could also measure the amplitude, but remember that the difference here is that we could easily make a mistake, couldn't we? So we could measure it from the bottom, like around about there, to the top there. But actually, that's not the amplitude. The amplitude is the halfway point. So it's where. So if I turned off the tap, and we'd have to wait for the water to settle down, it's from that middle. It's from that point there to wherever the water changes. Now, if I turn it back on again, we will see that the water level changes. So it's just a little bit down. I mean, it's about 0.2 centimeters. Anyway, that's how you would measure the amplitude. The other thing you'll notice about this is that if it's a bit easier to see if we get a graph, so we can get a graph here. Oh. If I measure the change, you can measure the change in water level at that point and the change in water level at this point, and you can see. Let's turn the amplitude down. You can see that one of them is slightly higher than the other, and the reason for that is because energy is lost as it goes from the tap to later on. And if we look at it from above, we see the reason for that is because it spreads out. So in reality, the waves would lose energy as they move away from the source. Not just because it spreads out, but also because energy is lost to the surroundings in other ways. So that's important, but we don't often talk about that at GCSE. So that's water, but similar thing will happen with sound. Now we can see sound waves move by a cone moving in and out, but it pushes and it squashes and stretches the air particles. So if we look at the actual particles, we see the particles are acting like this. If we look at in slow motion, we can see they're going backwards and forwards, like we saw. And so this is actually another type of wave, in fact. This is called a longitudinal wave, okay? And the reason for that is because the particles are moving, the oscillation is moving forward and backward, the same with the speaker here. And the information and the energy or the wave propagation is moving parallel to it. Okay, so this is the wave propagation. And the oscillation is moving in parallel. So that is called a longitudinal wave. The water wave that we looked at the beginning was a transverse wave, just like the one on the one on the string, and also a light wave is also a transverse wave. Although it's a bit weird and difficult to understand how a light wave is a transverse wave. Best thing to do at GCSE is just remember that it is a transverse wave.